Hello all, I am Dr. Praveen Chaurasia, working in the Department of Electronics and Communication Engineering at IMS Engineering College, Ghaziabad, which is affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Here I am talking about the lecture number 6 at where introductory portion of digital image processing I will cover, and in this lecture I will talk about the methods of digital halftoning process in the digital image processing and image storage, how we can store a image and how much the size importance is actually used and different format of image we will talk about in this lecture. Okay. So, in previous lecture we have talked about the methods of digital, we have started the methods of digital halftoning, at where we have also covered the difference between analog halftoning and digital halftoning. Okay. So, if we talk about the digital image processing, so digital halftoning is that much important, okay. Analog is not that much important. So, here we have already in previous lecture we have already covered the patterning portion, at where Relender's pattern we have used to transmit a image, and by using the patterning process you can obtain the digital halftone, and after that digital image can be identified and further we can transmit it for the processing frame. Okay. And in this lecture we will talk about the another two digital halftoning methods. Second one is dithering and third one is error diffusion. So, what is the dithering digital halftoning method? So, here this is the brief idea of dithering digital halftoning process. Here if you observe, the threshold is playing very much important role here. So, it creates an output image with the same number of dots as the number of pixel in the source image. So, if we have 8 cross 8 input image, then the output is also the 8 cross 8 output image. Okay. After that, if we talk about dithering, it can be thought of as thresholding the source image with a dither matrix. In dithering process, we have to have used the dither matrix. What it is? It is actually the matrix which is constant and repeatedly useful to further process of halftoning process. Okay. And it is well known problem of dithering is that it produces artifacts of patterns which is introduced by fixed threshold matrices. Okay. Now, see how we can identify, how we can find the output image. So, this is the output image and this is your input image. This is actually the digital image. So, here each and every pixel are having the value, okay, are having the intensity value. Now, see the first pixel is having the value that is 12, okay, and the repeated dither matrix which is actually useful for digital halftoning process, that actually compared with this input image, that is constant dither matrix, that is why it is known as dither matrix, okay, and repeatedly you have to use it, and this is a constant matrix. So, now see if your input image has a pixel which are having the higher value with respect to the digital with respect to the dither matrix, then it will generate the black portion. Now, see 12 is higher than 0, then it will generate a black portion. Now, see this one, it has the 51 value, this pixel is having a 51 value, and the dither matrix is actually loaded with the value that is 60 with respect to the same pixel. You have to use the same pixel, which is nothing but it is the first row and second column. So, that it has the 60 value. So, if we compare both of the value, then you will see the 51 is lesser than 60. So, it will just reflect the white portion and remaining are the greater. See, 34 is greater than 0. Similarly, 121 is greater than 60. So, all these two are giving the black portion, okay, black value of these label. So, see, the matrix is led repeatedly over the source image. Wherever the pixel value of the image is greater than the value in the matrix, a dot on the output image is filled, okay, otherwise it is unfilled. Similarly, if we talk about this portion, see, it has the value that is 34 and in Dithering matrix it has the value that is 110. You have to always choose corresponding pixel. If we talk about this pixel, then you have to choose this pixel only. Okay. So, 34 is lesser than 110, then this pixel is completely unfilled. Okay. So, that is the all about the dithering process which is present in a digital halftoning process. Okay. So, I think it is clear to everyone. Now, if we use this dithering matrix and if we use the dithering digital halftoning process, then if you have the original picture like this, then your output image is looking like in this manner. Okay. So, first diagram is actually giving the original image of a painter and this is the image of a painter which is actually generated by digital halftoning process via dithering process, okay, by choosing dithering method of digital halftoning process. Okay. Now, what are the actually specifications of these kind of methods? So, that point we can also identify. So, Dithering matrix defined by the user. Okay. So, user can define which kind of Dithering matrix is actually suitable for your particular matrix. That thing you can decide. That thing you can decide. After that, another point you can also observe here. Dither reads in an input image, compares each pixel with the corresponding element, as we have already said to you in previous slide. So, each and every corresponding pixel have to be compared each other. Okay. So, that is all about the dithering method which is present in a digital halftoning process. Okay. Now, if we talk about the another method of digital halftoning process, that is called error diffusion. Now, here the error word is very much useful. Now, see, using the error diffusion method, you have to find the error between the spatial coordinates. Now, see, it is also known as spatial dithering, okay, at where neighboring pixel is came into the picture. It sequentially traverses each pixel of the source images. Each pixel is compared to a threshold, same as dither, but what is the difference between dither and error diffusion? Error diffusion is a neighborhood operation, since it operates not only on the input pixel, but also its neighbors. Okay. So, neighboring pixel is also present there, and after identify the difference between the neighborhood pixel, you can obtain the output image in error diffusion method. Okay. So, dithering process of digital halftoning is there, but slight more advanced version of dithering is present in error diffusion, and error diffusion we are choosing to operate neighborhood pixel. Okay. Now, if we talk about the output of error diffusion, now see, error diffusion when compared to a dithering does not generate those artifacts introduced by fixed threshold matrices. In dithering process, the matrix is fixed. First, once user has been defined a dither matrix, then it cannot be changeable, but in error diffusion according to the neighborhood pixel it can be changeable. Okay. So, that is the difference between error diffusion and dithering method. Now, if we talk about the output of error diffusion digital halftoning process. So, see, if we have the original printer image in this manner, then after using the error diffusion digital halftoning, then your image will look like in this manner. This is more advanced rectification, or we can say halftoning, and very much clear to as very much cleared output as compared to previous two method, which is which is patterning as well as dithering. Okay. So, error diffusion is most advanced version of digital halftoning, because and it is actually specified by Floyd and Steenberg. Okay. So, that method they are proposing at 1975. Okay. So, that is all about the digital halftoning, and after that if we talk about the image storage. So, first of all we have to identify how many standard we have to generate an image in a digital format, or we can say in a storage format. So, if we talk about that is more widely used image file format, that is JPEG, Joint Photographic Experts Group. Second one is graphics interchange format. Third one is bitmapped. Fourth, True Vision Graphics Adapter TGA, PNG Portable Network Graphics, Tagged Interchange Image File Format TIFF format, EXIF Exchangeable Image File Format, and PCX, and many more. Not it is limited to that only, many more standard format are there. So, PCX stands for Personal Computer Exchange. Okay. So, these some of the file format are given there, and after identifying the file format, you can also identify the size of image. Now, how we can find the size of image? So, before going towards the size of image, we have to understand how many types of image we have. Now, see, if we talk about the binary image, now see here in this image two color are there. First one is black and second one is white, this one, that line is showing the another color. So, binary, if we talk about the binary matrix related to this image only. Now, if we talk about this image, then we have 0 or 1, at where the black portion are there, then we are choosing 0, and for white portion we are choosing 1. So, see, that is the portion related to white portion. So, here we are choosing 1 1, and that entire is black, see this one. So, we are choosing 0 0. Okay. So, related to this image we are obtaining the binary image. So, actually we are taking this portion matrix only, not complete portion. Okay. That portion we are not taking here, we are taking that portion only. Okay. That portion we are zooming it out. Okay. So, if we have a blackish part here, so see that entire portion is 0, because 0 is belongs to black portion. Okay. And that portion which is actually giving the white portion, so that is providing the 1 value. So, 2 value are there for binary image, 0 and 1. Okay. So, it is the first kind of image, that is binary image. Second kind of image if we talk about, that is grayscale image. Now, see, grayscale image is actually varying from 0 to white, 0 to 255 level. Total levels are 256. Okay. And 0 to 255 means, if we talk about 0 is the black portion color and 255 belongs to the white portion, then between the black and white gray color has been introduced. Okay. So, that is why it is known as grayscale image. Okay. So, if a matrix which is having 1, 12, 13, 255, 0, then we can say that is the grayscale matrix of grayscale image. Okay. So, now this is very natural range for image file handling. Okay. So, other grayscale ranges are used, but generally they are power of 2, because 256 is nothing but it is 2 raised to power 8. Okay. Now, how we can find the grayscale matrix? So, see, if we zoom it out that portion only. So, see that matrix is actually varying from 0 to 255. See, that is why we can say this is the matrix of grayscale image. Okay. That is the image which is belongs to the grayscale image, and after extracting of this portion in a digital form, then each and every pixel are holding this value, okay, which is actually varying from 0 to 255. So, see, the complete black portion is actually giving, the complete white portion is actually giving the 255, and completely black portion is giving the 0, which is not present in that portion. Okay. So, that is actually the matrix of grayscale image. Now, if we talk about another kind of image, that is called true color, or we can say RGB image. True color image, or we can say RGB image, that is the red, it is the composition of red, green, blue color. Okay. So, these 3 color we have to involve in this kind of image. So, if we are using 0 to 255, then according to these 3 color, then we have these number of possible color, that is 256 raised to power 3, then up to 1 crore 67 lakh 77,216 number of different possible colors in that particular image. Okay. Now, see, this is the RGB color image, and we are extracting that portion only. So, that portion are having 3 different gray level scale matrix. Now, see, if we are talking about red color only, then it will provide this matrix. If we talk about green level, then it will provide this matrix. If we talk about blue level, then it will provide that matrix. So, this pixel are having 3 different matrix. First one belongs to red, second one belongs to green, and third one belongs to blue. That is why we can say it has up to 1 crore 67 lakh 77,216 color. Okay. So, that is why it has more information related to all the colors, that is RGB. Okay. And one of the important image is also there, that is called indexed image. Most color image has only a small subset of color image of more than 16 million possible colors. It has much more as compared to previous one RGB. Now, see, for convenience to store and file handling, the image has associated a color map or color palette, which is simply all colors used in the image. Each pixel has a value which does not gives its color, but indexed to a color map. Now, see how we can identify the index image. Now, this is the index image. It has much more information as compared to previous one. See, this portion is actually we are taking into the extract, and indices of this pixel we are using. Now, see this one, and these indices is also the combination of these three color map RGB. Okay. So, each and every pixel is also giving the idea about RGB color format. So, these indices we are using in this matrix only. Okay. Now, come to the image file size. We have already talked about the binary image. First one is the binary image, second one is the grayscale image, third one is the true color image, or we can say RGB image, right, and fourth one is a indexed image. Okay. These kind of image we have talked about, but how we can find out the size of these entire images, and these entire images are also having different kind of standards, that is known as file format. Okay. So, if we talk about binary image, now see binary image. Now, binary image is actually giving the idea of 0 and 1. Okay. So, only you have to change one bit only, whether it should be a 0 or it might be a 1. So, see, if we have total number of row, that is 512, and total number of column, that is 512, then if we talk about the size of binary image, then only one bit is actually required. So, 512 multiply with 512 into 1, that is the actually size of your binary image. So, it will comes in bits in this manner, and if we talk about in bytes, that is up to 32 megabyte. Okay. So, and 1 byte is actually the 8 bit. 8 bits is actually comprises 1 byte. So, if you reduce it, if you divide it by 8, then it will generate 3200 768. Now, if we talk about gray level scale, then how many level we are using? We are giving the range from 0 to 255. So, if we talk about total 256 level, and it is the power of 2 raised to power 8. So, how many levels are there? 8. So, see, if we have 512 row, 512 column, then how many level we are choosing here? That is 8. So, 8 we are multiplying with this one, and after that you can find the size in a bytes in this manner and bits in this manner. Okay. So, around 262 MB is the 26 MB is the size of this gray level. And if we talk about another kind of image size, that is the color image size, or we can say RGB image, then how many colors are there? Red, green, blue, 3 colors are there. So, similar level are there, how many? That is 8. How many? What is the size? That is also same as previous one, but you have to multiply this 3, because one pixel are holding 3 different matrices. Okay. So, total size will become in this manner, that is around 78 MB. Okay. So, that is all about the image file size. Okay. So, related to this, I am taking the reference from Gonzalez, Jairam Ramesh, and the third one, that is Floyd and Steenberg, by which we can identify the grayscale, which is published in Proceeding Society of Information Display in 1976. Okay. So, that is all about the 6th lecture. Thank you all.